Hello everyone, welcome to my channel. In today's video, we are going to learn about normal distribution or Gaussian distribution. So it is the most common continuous distribution function for independent and randomly generated variables. So when you plot a normal distribution graphically, you will get a bell-shaped curve. I will show you in the next slide. So what are the characteristics of a normal distribution? So it is symmetric and unimodal. What is symmetric? What is unimodal? I will show you. Symmetric means, now if you see this particular, so this is a bell-shaped graph. So when you plot a normal distribution, you get something like this. Unimodal means that it will have only one peak. Symmetric means if I divide it into two halves, so this part is equal and this part is also equal. So next one is mean, median and mode are all equal. So it is having all the mean means the average of all the values. Okay, so that is mean, median and mode are all equal for this particular distribution. And one more thing to note is that normal distributions are symmetrical, but not all symmetrical distributions are normal. So if a graph is symmetrical, it doesn't mean that it is normal, but all normal distributions are symmetrical. Okay. And one more thing to observe here is that if you find out the sum, that is, these are the standard deviations. Okay, the sigma represents standard deviation. So 68.2% of the data belong to the first one standard deviation, -1 sigma, 1 sigma. Then 95.4% of the data belong to 2 standard deviation, and 99.7% of the data belongs to the 3 standard deviation, -3 this side and +3 this side. Now let us see one example, okay, where normal distribution can be applied. Suppose we want to, there is a set of data where the height of humans, that is the height of human is given, and the average height of human is roughly, suppose 175 centimeter, that is 5.9 inch, counting both males and female. So if we plot, that is for each and every human being some height will be there. So if we plot it, the normal distribution, we will get something like this. So in the chart we can see that the majority of the people have 175 centimeter average height of, this is the average height of human beings. Okay, taller and shorter people exist with decreasing frequency. So if there is if there are few people whose height deviates from this 175 centimeter, so the frequency is very less. So there will be very few people who will be having a height of 154 centimeter or 161 like this. And similarly 196 centimeter, that is the tall, 196 is 6.5 inch, okay, 6 feet 5 inch. So there will be very less people, less frequency of people who will be having this height. The majority of the people will be having this portion of height, that is close to 175 centimeter. So this is an example of normal distribution related to height of human beings. Now if we see the formula, so this is the formula in order to plot the normal distribution. F of x is equal to 1 divided by sigma root over 2 pi e to the power -12 x minus mu divided by sigma whole square. So here if you see, x is the value of the variable or data being examined, f of x is the probability of the function, mu is the mean, this is the mean, and sigma is the standard deviation. So for mu and sigma, the formulas all of you already know, I guess. So whatever is the value, you put it here and you will get the normal distribution curve. Now let us see some real life examples. Suppose weight of babies. So if we plot the weight of, suppose the weight of say 1000 babies are given. So if we plot that, we will get a normal distribution where the bell shape we will get, and the average weight of babies will be shown by the unimodal, that is by the peak. Okay, then similarly we can find the height of males, then blood pressure. So these are few of the real life examples. Now let us see how we can plot a normal distribution using Python. So first of all, we will import the libraries. We will be using NumPy. So import NumPy as NP. Since we'll be plotting the diagrams, so we are writing import matplotlib.pyplot as PLT. Now let the mean, as I have told in the formula itself, mean and standard deviation you definitely need. So suppose we are trying to find out the baby weight. Okay, so let the mean of the baby weight be 3.5 kg. That is, the average weight of the babies are 3.5 kg, we assume it. Then standard deviation weight, let it be 0.5. Then sample size, that is, we have collected data for 1000 babies, let it be. Now we are going to find out the normal distribution. So what we are going to write, baby weight is equal, this is one variable we have taken, which is equal to numpy np.random.normal. That is, we are going to call the normal, we are going to calculate the normal distribution. What we need, we will pass the mean. This is a inbuilt function. Okay, this is an inbuilt function. So we are going to pass the mean weight of the babies, standard deviation weight, and a sample size. So here it will go 3.5, 0.5 and 1000. So we have passed all these and it is present in this variable. Now we need to plot it. So there are various ways of plotting the graphs. So first of all, I will show you how we can plot it using kernel density estimation. Okay, so here I will just use one more package, Cbond. Okay, so I'll have to import that one. So let us import Cbond as SNS. Okay, so let us import this also. So after that, from SNS we are going to call the KDE plot. So here we will pass the baby weights, this part, and the color, let it be sky blue. You can give any color you want, and line width I have given as 2. Now title will be distribution of baby weight, X label, that is X-axis label, will be weight, and Y label will be density, and grid we are going to give. So I am writing it true. And now plt.show. Let us run this one. So you see, this is a sort of graph that we can see. So if you see the curve, you can see that clearly it is a bell-shaped curve. So average weight is 3.5. Okay, and standard deviation I have given it as 0.5. You can change it according to your wish. So this is one way of showing the normal distribution. Another way is, let us cut this part. Okay, so another way is we can plot it in terms of histogram also. So let us remove the comments here. So in place of KDE we can use this histogram also. So we will just write down PLT hist. Similarly, baby weights we are passing bins equal to 30, that is it will collect by 30. Then these are the color and edge color I have given, title, X label, everything already I have explained. Let's run this one. So this time you see you are the normal, it is showing the normal distribution only, but it is shown in form of histogram. Okay, so this is another way in which you can plot the normal distribution. There are many other ways also present. So these are the most common ways that are being used. So that's all for today's video. If you like the video, please do like and subscribe. Thank you everyone.